Okay, so the rest of the unit is just really working with exponents and radicals at a basic level, and estimation some irrational numbers. So we're going to get right down to it with some examples. Okay, so we're going to find the value of some of the following expressions. And we talked about, hey, wait a minute, you have a negative sign inside of a radical. That's not a thing. But it is. It is, especially if that index of that radical is an odd number. Right? If the index is an odd number, it's okay to have a negative inside the radical, because I can do a negative times a negative times a negative, and that equals a negative, right? So if I cube a negative, I can have a negative as an answer, right? But if I square a negative, right, I can't. That's going to be a positive. Or so anything to the odd, right? Anything where the index is an odd, I can have a negative. Anything where the index is an even, I cannot. Right? So it's okay to have a negative sign inside the radical, as long as the index is an odd number. Right? In fact, that's going to clue you in that the thing that you had to multiply together 3 times, or whatever number of times, was a negative number. Okay? So that's really the only thing that's going to indicate to you. Okay, so this one is, hey, find the value of each of these things, right? So, well, this one's pretty easy, right? This one, I multiplied 1 together 3 times to get, or sorry, negative 1 together 3 times to get negative 1, right? So this is cube root negative 1 times negative 1 times negative 1, right? I did that 3 times, and I got negative 1. Right, so that's how that whole thing happened, right? So what about 27? Well, if you remember that if you memorize your tree, your cube roots numbers, you'd remember that this was the cube root of 27 was 9. So the cube root, so or 3, not 9. I'm sorry, that's wrong. 3. So if you remember that 3 cubed equals 27. But if you didn't remember that, therefore negative 3 cubed equals negative 27. Right? So therefore the cubed root of negative 27 equals 3. Right? But if you didn't remember that, you could, right, break it up into its base components. Right? Be like, okay, what is 27? Well, I go 3 times, let's put a negative sign in front of that, 3 times 9. Negative 3 times 9 is 27. Okay, we'll keep going. Right? Negative 3 times 3 times 3. Okay, well, that equals 9. Okay, well, if I made all 3 of these negative, okay, well, then I could pull out, I have 3 of the same number, my index is 3, so negative 3 is, it's a perfect cube, it can come out, negative 3 is my answer for that one, okay? And it's a little bit more right for here, like, because I don't remember the cube root of 343, I mean, I can't remember that that's 7, it is, right? But let's say, for instance, I don't remember, it's going to be positive, right? If I can break down 343, and I'm like, man, that seems like a prime number, but maybe it's not. 343, and let's see if I divide that by, oh man, let's see, divide it by 3, just for instance, 343, and I divided that by 3, 343, and I had, because it has a nice fat 3, that didn't work out, 343, and I divided it by 49, and it ends up being 7. Okay, or I divide it by 7, okay, and it ends up being 49. So this is 7 times 49, the cube root. Okay, I'm like, okay, cool. Well, this is also 7 times, and 49 breaks up into 7 times 7. And hey, look, I have 3 7s, right? So this is a cubed root, right? 7 times 7 times 7 is 49. I need 3 of them to make a perfect cube, so this equals 7. Okay, so that's kind of the concept between all that stuff. Okay, so now if I have to solve an equation here, okay, well, I'm like, okay, well, how do I solve for y? Let me zoom in here and solve for y. Well, in order to solve for y here, I got to take the cube root of both sides, right? Because I need to get this as, I need to undo the cubed over here. In order to undo the cubed, I need to do the opposite function, which is the cube root. Okay, so I need to do the cube root of both sides. Well, the cube root of y cubed is y. Okay, the cubes cancel out, radical goes away, and I just have y left over. And then the cube root of 8 is 2. Because 8 times, or 2 times 2 is 4, times 2 is 8. All right, and how about this one? This is negative 64. Again, to cube root of both sides. The 3's cancel out. I have a. All right, and then this is going to be equal to the cube root of negative 64. 4 times 4 is 16, times 4 is 64. I do the same thing with negatives. Negative 4 times negative 4 is 16, times negative is negative 64. Right, so the cube root of negative 64 is negative 4. Okay, then we have a 512 coming up here. And then you just got to be like, okay, well, this is the cubed root. The cubes cancel out, right? Whoops, here we go. The cubes cancel out, and I need to take the cube root of 512. This is n. Oh man, 512, I can't remember 512. Cube root of 512. Let's see if I can break this down into, like, well, 2 would be easy, but maybe let me try 8. Well, it's 64, so 8 times 64. Okay, let me keep going. 8 times 8 times 8, because it's 64. Oh, look at that, I got 3 8s. All right, so those 3 8s come back, and then so this is going to be equal to 8. Right, so this is going to be equal to n equals 8. Okay, so that's how that whole thing works there. Okay, so moving on to a new concept here. Okay, that was 3. Now we're moving on to 4. Let's keep going there. All right, so here we have. We're trying to approximate the values of these numbers. Okay, we have some approximate values of these numbers here, and you gotta remember, well, if I have my tables here and square root of 78, what do I have? Perfect square. That's underneath 78. I have the square root of 64, which is 8. Right, and then that's the below end, and then I have the square root of 81, which is 9. Okay, so between 78 and 64, I have, so it's gonna, so that my numerator here is going to be somewhere between 8 and 9. Between 8 and 9. How much between 8 and 9? Well, it's closer to 9 than it is 8. So it's going to be almost 9. Almost 9. Right? So it's like, we'll say it's like 8.8-ish, right? It's going to be divided by 4, right? So my approximate value, maybe we could even factor this thing out a little bit, right? If I could do 78 and I break it down, it's divided by 2, right? 78 divided, think about that for a second, 39. Right, it doesn't really help me very much because 39 is a prime number, right? Yeah, so even still, it's 8 is the best way. This is the best way to go about it, right? So this is about 2.2-ish. It's about approximately like 2.2-ish, right? And let's see how close I got here. Okay, so I got 78. Let me see here. Let's see. Can you see better if I do this? No, this is the scratched up one. All right, so 78. Take the square root and divide it. Oh, 8.8. I was pretty close. Divided by 4, and it's like 2.207. That wasn't too bad. Okay. So now I have the 78, which is, like I said, 8.8-ish. This was 8.8-ish. I'm going to multiply it by -3, right? So 8.8-ish. So 8.8-ish, 8.8-ish times -3. This is almost 9, right? This is almost 9, so 9 times -3 is 27. But I'm off by a factor like 0.2, so I'm going to subtract 0.2 times 2, 0.2 times 3, which is, well, that was weird, which is 0.6, right? So this is going to be like or I'm going to add 0.6. Yeah, it's going to be like I don't know, like 26.4, so -26.4. So let's see how close I was there. All right, so 78 square root times 3 negative is like 26.5, right? So that was pretty close, Okay, and then we have this again is 8.8 plus 5, so it's like 13.8. Okay, so there you go. So that's that one there. So that's kind of how you do that one. Okay, here's like one with pi. Okay, here's one with pi. So pi is like 3.14, right? And we're gonna multiply that by 2, right? So it's like it's like 6.15. No, sorry, 6.3. It's like 6.30. Right? This is like 3.14 plus 1, so it's like 4.14-ish, right? And then if we're gonna put these on a number line, so C would be like 2 and C would be like 6 and like third-ish, right? So this is C, right? And then D would be like 4 and like a little bit more, so like there, right? So that's kind of how you do those ones. Okay. All right. Here's some examples from like how do you compare a couple of these. Well, this is pretty easy, right? Which one is greater? Don't get tricked by absolute values. Okay. These are both going to be negative. Well, this is going to be -8, right? This is going to be a smaller value that's negative, right? Because this is going to be -8. This is going to be like cube root, so this is going to be a smaller negative number, right? So this is going to be a smaller on the number line. So this is going to be like square root of -60, the cube root of -64, and then this is going to be -8, which is the square root of 64, right? Because cube roots are always going to be smaller than square roots. Okay. Then we have here, we got 11, and we'll do this one. We're going to do 3 pi, which, like I said, was like, what's 3.14? So that's going to be like 9 point, I don't know, like 4.2, right? And then this is going to be pi squared, which is like 9 and some change plus 1, so 10. So it's automatically going to be 10, so this is going to be like that, right? So it's not really like really close math, but it'll get you really close. Like this here is a little bit more than 27, and we know the cubed root of 27 is 3. So it's going to be a little more than 3, a little more than 3, and then 7 halves. 7 halves is, well, that's going to be a little, that's like 3 1/2, right? So I'm thinking that that's going to be the bigger one, right? So if you look at 30 to the cube root, it's definitely not bigger than 3 1/2. Okay, so that's that one. Okay, and here we're going to identify a rational number between 7 and 8, right? So How about we do, well, 7 squared is 49, right? So square root of 49, and 64 is 8 squared. So how about we do a square root of something in between that, like 50? That's going to be between the square root of 7 and 8. Okay, and then let's go down over here, and this is going to be another like comparing the two things. So I don't want to do anything more like that. How about the next page? All right, so now we're going to plot some stuff on a number line. Okay, so in order to do this, let's identify any negative values. There are no negative values. So now we're going to kind of like, let's see if we can convert these to a relative decimal point. So here we have a 3.14, right? So this is going to be like your pi. Okay, and then we have a 19 halves. So 19, so if it was 18 divided by 2, it'd be 9. So this is like 9.5. This is like, or sorry, 18.5. No, that would be 9.5, excuse me, 19.5. So it's 9.5, so we got that one done, we got that one done. Now we have the cube root of 27, which we know is 3, right? So this is the cube root of 27. So we got that one done. The square root of 48, okay, so the square root of 48, this can be 6 times 8, it's 48, and then we have a 3 times a 2 in the 6, and then we have a 2 times a 4 into 8. So we have a cube root, a square root there in 2. We have another square root there in 4. So 2 times 2 is 4, and we have left over 4 square root of 3. All right, so it's at least 4. And then times the square root of 3, which is about 1.7. So it's almost 8, but not quite. So we're going to say it's like square root of 48 is somewhere between 7 and 8. Let's take a look, see if we're right. 48 square root is, no, it's about 7. I was a little off there. It's about 7. So 4. Square root of 3 times 4 is about almost 6.9. So it's about right there. This is about square root of 48. It's about right there. It's almost 7. Okay, and then we have the cube root of 530. Okay, so if you remember your long terms there, we can break down 530. Let's do 121 here. This is the square root of 121. Square root of 121, that's 11. Square root of 121 is 11, right? So, so that's way out here. This is 11. This is the benefits of having memorized your tables. Then the cube root of 530, right? So, it's 8 times 8 times 8. So 8 times 8 times 8 is 512. So 512 is that. What's 9 times 9 times 9? Much better than that. 9 times 9 times 9 is like 729. So this is really close to 8, right? So it's going to be like here-ish, right? So this is going to be like cube root of 530. Alright, so 530 to cube root is like 8.09. I was a little bit too far. It's like right there. Alright, so that's that one. Okay, so as long as you're like within the band, I think initially I would have been wrong with this one because I was like here instead of here, right? But if you're along between the numbers and relatively closer to the right number, I think you'd be okay. Okay, so that's that. Really, they're just like ballparking it and understanding where the irrational numbers lie and understanding how to break down into factors these things. Not possible because this is an even number with a negative sign inside of it. Possible either way. Okay, possible, not possible. Okay, between which two perfect squares does 23 lie? right? So you have, let's see, 6 and 5, right? 6 squared is, nope, that's not right. So between, not 6, it's going to be 4 and 5, right? So 4 squared is 16 and 5 squared is 25. So 23, so the square root of 23 is between 4 squared and 5 squared, right? So there's that one. Like that. Okay. And then we have 23, like so. So that's that. Okay. So I hope all that stuff makes sense. This will be being posted up shortly.